Here's the review for your upcoming test. The first 6 problems are just going to be solve quadratic equations. In some cases, you'll be told what method to use. In other cases, it'll be up to you. So like in this example, solve any method you want. So you could try, your choices here, of course, are the square root method. You can use factoring. You can use the quadratic formula. Now we have graphing as an option. However, since you can't show work for that, and we have to use only our graphing calculators, it's not a very efficient way to do it. So let's focus on these 3 because they are the most efficient way. So I've got my polynomial here. I can solve any way I want to. It's equal to 0. That's good. There is no GCF. We just got a 1 here, and 16 and 60. Well, with the 1 here, 1's only divisible by 1. So, and only x in the first term, or x squared. Here's an x, and no x's in that last term. So it's all set up for either factoring or the quadratic formula. We couldn't use the square root method in this problem because there is a b term. That b term is at 16x. And you can't use the square root method if you have that, except under some special conditions. So let's try to factor this one. And maybe this will work, maybe it won't. And I go, well, to get an x squared, it has to be x times x. These two, remember we call these r and s. They just have to equal 60 here. 1 times 60. And so they also have to add up to this number here. So that's what they add to. This is what they multiply to. So I'm going to use a 6 and a 10 because that multiplies to 60 and it adds to 16 if they're both positive. So I've got it factored. Now don't forget, this is the zero product property. If A, we'll call that A here, times B, we'll call this factor B, equals 0, then either A equals 0 or B equals 0. When those have to be true, I subtract 6, there's one answer, -6. I subtract 10, there's the other answer. And so those are the solutions to that quadratic. We'll go a little quicker now. Again, solved by any method. Here's one where, again, as we start to look through it, we could think about the square root method, factoring, and then lastly, the quad formula. This one, you could use the quadratic formula, but you'd have to get it equal to 0 first. I happen to notice, though, this part right here factors very quickly as an x and an x, and to get a 4 here, it's got to be 2 times 2 because they add to the 4 in the middle. And because I noticed it factors that way, I can rewrite it as x plus 2 squared equals 49. And now I can use this square root method. Now remember, when you square root both sides, you always get plus or minus, and that plus or minus means a positive or a -7 is a solution. Now, some students are still having a hard time figuring out what's going on. Here's what this means. It means x plus 2 could be equal to a 7, or x plus 2 could be equal to a -7. That's what this plus or minus means. And then when you solve these, it gives you the 2 answers. Subtract 2, you get -9. Now, when we've shown this in class, we usually don't go through all those steps. I say, hey, just subtract your 2 right at this line. You get -2 plus or -7. But then you still do the math here, though, to get your final solutions. -2 plus 7, that's the 5 down here. -2 minus 7, that's the -9. So there it is with a little combination, kind of factoring and the square root method. But I do want to show you that you can solve it with the quadratic formula as well. And I'm going to fly through this one kind of just so it's a little bit, it didn't take too much time here. So I'm going to substitute into the quadratic formula and see if I get the same 2 answers. Now remember, if I use the quadratic formula, I've got to be in standard form to begin with. And this right now is equal to 49. While I'm in standard form, I don't equal that 0 there. So we subtract our 49 first. And that's going to give us x squared plus 4x minus 45, I believe, equals 0. Now, if you did this, you could still try and factor this polynomial at this point. X and x, 9 times 5 would give me 45 if I make this positive and negative. And there's my two answers, negative 9 and 5. So we get the same two answers if we set it equal to 0 and solve it. And then lastly, quickly, we'll do it in the quadratic formula to show it's going to work regardless. So I'm using my b is 4 here. So I got negative 4 plus or minus square root of b squared. 4 squared is 16 minus 4 times a times c all over 2 times a, and a is just 1. See, when I put my b in the squared, I just did that in my head. So now I've got a 16, and I'm going to go plus here. I'm doing plus because notice there's my 16. I got minus sign here, but that's going to be a negative 4 times a positive 1 times a negative. And these two negatives, when they multiply, will give me that positive. So now I just have to do 4 times 1 times 45, or 4 times 45. I know it's going to be a positive number. 4 times 5 is 20, carry your 2, 16, 17, 80. All over 2 times 1. Negative 4 plus or minus the square root of 196 all over 2. And I get out my calculator, and the square root of 196 is 14. And see, now I can do what I was just talking about on the other side there. I'm going to do the positive 1, negative 4 plus 14. And then I'll do the negative 1, negative 4 minus 14. Now that's going to give me two different numbers, and both of them have to be divided by 2. So negative 4 plus 14 is 10, and that has to be divided by 2. So there's one of my answers, just like we had before. The other answer, I go negative 4 minus 14, that's negative 18. Divide it by the 2, that's negative 9, our other solution. So there we've solved it 3 different ways, always getting the same result. Solve by any method, let's see, I look at it real quick. I go, yeah, it's quadratic, it's equal to 0, everybody's divisible by 2, and I don't want a negative out front, so I'm going to divide this entire side by negative 2, each term, and this side by negative 2. And so I get 2x squared minus 3x plus 1 equals 0. Then I might try to factor this one. Now it's going to be a 2x here, so I could try and brute force it and go 2x and x. To get a 1, it's got to be 1 and 1. This product is 2x. This product is 1x. I want them to add up to the negative 3 in the middle, so I'll make them both negative. So there we go. I think I've got it factored right there. I'm going to do it a factoring a second way, though. I'm going to use that RS method so you can see that. So if I'm going to use the RS method, I go A times C. In this case, 2 times 1 equals 2. And so I want to find an R and an S value that multiply to 2, but at the same time, they have to add up to the B value, which is negative 3. And so to get 1 and 2, you go 1 times 2. To get to be a negative 3, they both have to be negative. So they multiply to 2, they add to negative 3, and then I'd write, because my A is 2 up here, I'd go 2x minus 1, 2x minus 2. Everybody in this factor is divisible by 2, and so it's 2x minus 1 times x minus 1. And you'll see I got the same thing up here, doing it by brute force. Regardless, now that I have it factored, don't need that parenthesis, I just take each of those factors, set them equal to 0, and solve. So add 1, divide by 2. There's one answer. Add 1. There's the other answer. Use any method. There's my ax squared plus bx. My c's on the wrong side here, so let's get that thing equal to 0. Then I'm not going to try to factor this. This thing looks, that 3 causes a problem, and that 35, 3 times 35 is 105. No, I'm not going to deal with that, so I'm going to just write down a is 3, b 22, c 35. And unless you're super experienced, I would always just jot down my quadratic formula and then take my time and just substitute. So it goes negative, b is 22, plus or minus the square root of 22 squared minus 4 times a is 3. And c is 35. And that's all over 2a. Or 2 times, and a again is 3. So there's the entire substitution. Now, the information underneath the radical, this part right here, that's called your discriminant. Oops, shrink that down, discriminant. Notice it doesn't include the square root, it's the stuff underneath the square root. And when you have a quadratic formula, a good idea is to just grab your calculator, type in exactly what that discriminant is. So, can't see my calculator, but I put parentheses 22 and parentheses squared, and I just hit minus 4 times 3 times 35. And I go enter. And it tells me this right away. Negative 22 plus or minus the square root of that stuff, my discriminant, is 64. And now I just simplify. Let's see, that's negative 22 plus or minus square root of 64 is 8 over 6. And now I can find my two solutions. Negative 22 plus 8 is negative 14 over 6, which is negative 7/3. And then I also have to do negative 22 minus 8, that's negative 30 over 6. It's negative 5. There's my second answer, using the quadratic formula. Solve by any method again. Notice this quadratic has no b term. It's got the ax squared right here, no bx, but there's the c. And if you don't have a b term, you can use the square root method. I'm going to isolate the x squared, divide by 49. So we've got x squared equals negative 4 over 49. Then we'll square root both sides. There we go. X equals plus or minus. And you separate these two. And you just keep working, you simplify. And I'm just going to look at the top here first. And I go, okay, square root of negative 4. So an I comes out. That gets rid of the negative. And the square root of 4 is just 2. So I can square root the 4, I can square root the negative, and I just get a 2i on top. In my denominator, the square root of 49, that's a perfect square, and its square root is 7. And so I get two answers for this. I got, hey, x is either 2i over 7. This, by the way, is exactly the same as 2/7 with an I stuck to the side. And the other answer is x could be negative 2i over 7. That negative could be out front like I've shown it. That negative could be in the top, in the numerator, like this. It could even be in the denominator, but that's generally considered bad form. Next one. Oh, this is very similar. No b term. No b term, man. I'm just going to get that x squared alone. Divide both sides by 6. That's just 9. Square root both sides. Two answers. Plus 3 minus 3. Done. Hey, that's all of our solve. any way you want to. Let's see here. Use the graph to determine the number and type of solutions of the quadratic equation. So let's look at each problem here. We got to figure out the number and type. So by number, our choices are, does it have let's list the number of real solutions. Number of reals could be none, could be 1, or it could be 2. Number of imaginary solutions, the ones with the i's in them, could be 0 or 2. It turns out they always have to come in pairs. And even if, like, the real number is a 1, we actually count that twice. Remember, it's multiplicity. So if you get one solution, it really counts as 2 solutions. So even real numbers technically only come in either 0 or 2 real number solutions. So let's take a look at the first one here. Here's our equation. Here's the graph of our equation. Hey, when does it equal 0? That's its solutions, and so it crosses here twice. These are real numbers, and so we'd say this one has 2 real solutions. We're not giving the solutions. It didn't ask for the solutions. It asked the number and type. Question 8 here. There's our quadratic. Here's the equation. Here's the x-axis. Notice it just touches it one time. So we'd say it has 1 real solution. Now I want to emphasize something here, though. I am going to say with multiplicity of 2. And that only means it happens twice. Number 9 here, here's our x-axis. It never crosses it. So this one has 0 real solutions, but it has 2 imaginary. And then number 10 here, the equation, parabola, opens upside down. See that negative x squared? That a is negative, so it's upside down parabola. It still crosses the x-axis here in 2 spots, so it's got 2 real solutions. Number 8, we got ourselves a word problem kind of here. We got the Freedom Tower. They give us an equation. How long will it take the object to hit the ground? What's the height of the object? 3 seconds after it's been dropped. So f of t here calculates height. So t equals negative 16t squared plus 1776. And so they're really asking 2 problems here. In question A, they're saying, when does it hit the ground? Well, when it hits the ground, its height, given by the function, is 0. So we take this equation and we just set it equal to 0, and we try to figure out what the t is. This won't be too bad because there's no b term in it. And because there's no b term, we can just isolate the t squared. So I'm going to divide by negative 16. So I get t squared equals, I think that's 11 there. 1776 divided by 16. 111, yeah. And so t equals, and this is where I'm square rooting both sides, plus or minus the square root of 111. And I'm just going to use my calculator, square root of 111. And it gives me 10.5 seconds. So it's going to take it that long to strike the ground. Question B then is asking the same thing, except when or how high will it be after 3 seconds? And so if f of t tells us your height, and they're saying, hey, what if t is 3? It's really just asking what's the f of 3, which means we just substitute in. Let's see, that's negative 16 times a 9. You got to square before you multiply there. And then I'm going to get out my calculator. 16 times 9 is 144, so that's negative 144. 1976. Looks like it's going to be 1,632 what? That's measured in feet. So feet. Tie. So it starts at 1,776 feet. And after 3 seconds, it's going to have fallen, I don't know, about 80 feet maybe? No, about 140 feet. Question number 9. Oh, right. This is a subtraction problem, and these are two complex numbers. They got a real part and an imaginary part. The first thing I would do is notice because of this minus sign here, you're going to have to distribute that. So it's negative 2 minus 5i. When you distribute that negative 1, it becomes plus 4 and minus 2i. Now, when you add complex numbers, there's the real part, there's the imaginary part. And when you add them, you can only add real stuff to real stuff. So if I was adding something like this, my answers would be a plus c, the real part added together, plus my imaginary part added together. Like so. So in this problem, here's my real stuff, that's 2. Here's my imaginary, that's minus 7i, and you are finished. Last problem here, very similar to the first one, except notice there's nothing in between the parentheses. The parentheses are bumped up next to each other, so that implies multiplication here. And so let's distribute. 3 times 1 is 3. 3 times negative 6i is negative 18i. Negative 3i times 1. And negative 3 times negative 6 is positive 18, and I times I is I squared. Recall, I squared equals negative 1. So, 3, here's imaginary stuff. This little thing right here is 18 times negative 1, because I squared is negative 1. And 18 times negative 1 is negative 18. So we've got a negative 18 tacked on out here. And so this I squared became a real number at that point, and so we got a 3 minus 18. And this would be your complex answer. And that's it.